For the chapter related to slope and deflection, you people have to know few basic things before going deeper into the topic. So let us discuss about the same today. Okay, so when you were talking about slope and deflection, let us first know the definitions of both slope and deflection. Okay, so when you're talking about the definition of deflection, let us consider deflection. Okay, so what is deflection? It is the vertical distance of the beam which is measured before and after loading. Okay, so if you are considering a diagram here, for example, if I consider a simply supported beam, suppose this is the simply supported beam, this is point A and this is point B, these are the two ends of the simply supported beam. The reactions, these are the supports at point A and point B. So obviously the reactions acting at point A will be RA and RB. Okay, and suppose let us consider that at the mid section of the beam or the mid span of the beam there is a load which is denoted by W. Okay, now when we will consider this type of condition, then let us consider that the beam is elastic in nature. Okay, so if the beam is elastic in nature, then when we apply W amount of load at the midspan of the beam, then the beam will tend to bend like this. So this is the nature of bending of the beam. Okay, and this after this deflection takes place, the nature of the beam, this curve that you are getting here is actually known as the elastic curve. Okay, elastic curve, right? Now when you're talking about deflection, then as I have already said that it is the vertical distance of the beam which is measured before and after loading. So before loading the beam was AB, and after loading, as you can see, you have got a curve like this. This is the final deflection after application of W amount of load here at the mid span. The deflection after the deflection of the beam will look like this, right? Now as deflection is the vertical distance which is measured before and after loading, then in this case, if you are measuring, for example, if you are measuring this distance, this vertical distance, then you can naturally say that this is where the maximum deflection takes place, and this is where we find Y max, as because deflection is denoted by Y. Okay, similarly you can see at point A and point B there is no deflection, because at point A and point B these are the two support points, and here no deflection is there. Therefore at point A and point B the deflection is minimum. It is understandable, right? You have to keep this in mind that in this case the maximum deflection takes place at the midspan if you are considering this particular case, which is in case of a simply supported beam. Okay, where the load is applied at the mid of the span, right? So let us write down the definition of this deflection. So the definition of deflection is, it is the vertical distance of the beam measured before and after loading. Okay, right? So obviously it will be denoted by Y, denoted by Y, right? And obviously you can understand that at the 2 points where there are the supports, in case of simply supported beam, the deflection is minimum, that is equal to 0. That means at the support points, deflection is minimum, that is equal to 0 in this case. Okay, but in other cases, if you are considering any other type of beams, then the scenario will be different. That we'll be discussing later on. Okay, now what is slope? So this is about deflection. Let us discuss about slope. Okay, and let us consider the same diagram itself. We have considered here a simply supported beam. Now these are the two support points. At the mid section of the beam there is a load given, that is W. Now what is slope? It is the angle in radians measured between the tangent to the elastic curve and the original axis of the beam. Okay, you can say like this. Okay, so let us write down the definition. It is the angle in radian measured between the tangent, tangent drawn at that point, drawn at a particular point to the elastic curve and the original axis of the beam. Right, now if we are denoting the slope here in this particular diagram, then let us draw a tangent at point A. So if you are drawing the tangent at point A, the tangent will look like this. Tangent at point B will look like this. Okay, and if you draw the tangent at point C, if you consider this point to be point C, then the tangent will be this. Okay, so you can see, if you are considering the angle formed here is theta A, and if you consider the angle here is theta B, and here the angle is theta C, then it is clearly visible that at point C the slope is equal to 0, because the angle between this and these two lines are parallel. That means theta C will be equal to 0, and at theta A and theta B you are getting the maximum slope. Okay, so theta A and theta B are the two angles at the support points where you are getting the maximum slope, right? So slope is denoted by what? Slope is denoted by theta. Okay, and it is also denoted by, or it is denoted by dy dx. Right, this you have to keep in mind, because later on when we discuss about the derivations, then we will use dy dx as slope. Okay, in some conditions we will also consider theta as the slope. Okay, next thing is, let us discuss about the other conditions, that is the boundary conditions. Okay, so let us discuss about boundary conditions. Boundary conditions. Now what are boundary conditions? We will consider two cases. One is in case of simply supported beam. So we'll consider a simply supported beam here. This is a simply supported beam, okay, where W amount of load is at the midspan. We are considering two conditions because these two conditions are included in your syllabus. So another is in case of a cantilever beam. So cantilever beam, as you all know, that one end is fixed and the other end is free, right? So this is point A and this is point B. This is also point A and this is point B. This is simply supported beam. This is cantilever beam. Okay, cantilever beam. I'm using the short forms here. Okay, now if you are drawing the elastic curve, it will look like this in this condition, and here you are getting maximum deflection, that is y max. Okay, if you draw the tangent here, then this is theta A and this is theta B, right? And this is point C. In this condition also, the deflection of the beam will not start from point A. It will start after a little bit of span. Suppose from here it will bend like this. This is the nature of bending in case of cantilever beams. Okay, so if the total length in both the cases, if you consider that the total length is suppose L, Here also the total length, if you consider as L, right, then you can see in a cantilever beam that the maximum deflection is at the free end of the cantilever beam. Here is the maximum deflection. This is the vertical distance between the elastic curve and the original axis of the beam. So here Y max, you will get it at the free end, right? And obviously if you consider the weight here, the weight should be here at the end. The vertical load will be acting here. Okay, so deflection in case of simply supported beam, if the weight is at the midspan, and deflection in case of a cantilever beam if the weight is at the end or the free end of the beam. Okay, so in this condition, if you notice the first case, that is for simply supported beam, number one condition that we can notice is at point A and point B, you are getting the deflection as 0, right? At point A and point B, the deflection is 0 because there is no vertical distance between the elastic curve and the original axis of the beam. Okay, so here in both these points, at point A and point B, deflection is 0. Deflection is 0. Okay. Number 2, at point C, you can see at point C the deflection is maximum. That is why I have written here Y max. Okay, so at point C, deflection is maximum, max. Okay. Number 3, at point C, slope. What is the slope at point C? Slope is the tangent drawn at this point. So this line is parallel, this tangent is parallel to the original axis. That means the slope is 0, right? And number 4, at point A and B, that is at both of these points, you can see that the slope is maximum, theta A and theta B is maximum. So here at point A and B, slope is max, right? These are the 4 boundary conditions in case of a simply supported beam when it is loaded in this particular fashion. That means the load is acting at the center of the beam, right? Now in case of cantilever beams, if you want to find out the boundary conditions, number 1, let us consider the deflection at point A. So as you can see, as I have already said, that the bending of the beam will start from a little bit of distance after point A. That means at point A, the deflection at A, the deflection will be, deflection is how much? It will be 0. Here there is no deflection, so the deflection is 0, right? Number 2, what is the slope at point A? So slope is 0 at A. Slope is 0 at A because the tangent coincides with the axis of the original axis of the beam. Therefore the slope at point A will be also 0. Number 3, you can see that is at point B, at B, both deflection and slope will be maximum, is maximum, right? You can see that if you draw a tangent here, if you draw a tangent like this, then the angle that you are getting here, theta, is maximum in this condition. And as you can see that the vertical distance drawn from at that point to the axis is Y max. Therefore at point B, deflection and slope is maximum, unlike the previous condition. So you have understood clearly that in case of simply supported beam and in case of cantilever beam, things will be different in both the conditions. Okay, so thank you.